I'd just like to give everybody a little update on our loop making project. The progress I've made to date is getting a proof of concept built, mostly so I can get all the components laid out, kind of understand how this whole machine works, but I just want to go over it with you quickly. I started out with this 6-axis robotic arm. This is from Robot Anno in China. At the price point, it's a pretty robust machine. It's all machined aluminum, probably castings and then machined. It's got 5 servo motors for 5 of the axes, and then the end motor is a stepper. However, it's got harmonic drives. It really holds position pretty well. And again, this was not a highly expensive arm here. So I integrated that with pneumatics. I custom made this loader system. This rack right here is what will hold the loops in position prior to getting grabbed by the robotic arm. So the loops go in there like that. These racks actually come off. There'll be numerous racks. We can preload these so we can have an operator putting the white tabs on and sanding the ends, load them in the racks, have them set aside, and try to keep this machine running at a constant rate. This machine should be able to bond 75 loops per hour. I can't show you today any of the rubber loops actually getting bonded because I'm having issues with this adhesive pump, and I've ordered some more parts. I'm confident I'll get it resolved, but that's really the only thing right now that I have an issue with. Everything else I believe is going to work fine. And I'm going to show you this in operation quickly. This is the robot control box. Everything that happens and this is initiated out of this control box. So everything's synchronized. There's one program. It's Simple Machine G-Code. It works really well. There is another programmable controller that runs this rail, but it's actually kicked off inside this control, so it's tied in. So this isn't like a independent controller out here. Again, I've used pneumatics. I tried to use everything I could find off the shelf. I felt for repair purposes and stuff, I wanted to make it as simple as possible. A lot of the parts on here, all these brackets, this unit here, this adhesive stand, they're all 3D printed. I tried to incorporate 3D printing where I could. Again, it makes it simple. If we need parts in the future, we can make them easily and at a reasonable price. The whole system works on 110 volts and 100 psi air pressure, so we will need compressed air to operate this. So this is laid out on a bench, and again, it's for the sole purpose of getting all the components together. You'll see I have nails holding some things in place. Obviously, that won't be in the finished product. There's going to be covers on certain things. All the wiring needs to be routed neatly and shielded and things like that, and that'll all be done. This is just a proof of concept. If we turn over here, this is actually going to be the enclosure for the entire system. So this is made out of 80/20. It's extremely sturdy. It's got a 1/2-inch plate of Mix 6. That's Blanchard ground aluminum. It's a very accurate surface. We wanted something that's very stable because the robotic arm, when it swings and things like that, it moves about, it creates inertia and can move things, and we want to hold tolerance. This table, when it's done, again, it'll house everything, and then there will be plastic barriers slid in here. There will be access for the operator, but as far as the operator getting in there and getting hit in the head with the robotic arm or whatever, that'll be a safety feature. So, anyhow, we can kind of come over here. I'm going to go ahead. The operator will have one button to push. There's an emergency stop, but normally it will simply press the start button. robotic arm now is going into position to pick the first loop on the rack. Again, there's pneumatic grippers that close on the loop. It picks the one end of the loop out, moves it over. Now it's in position. This adhesive pump is running. If it was operating properly, it would be putting adhesive on the end of the loop. This rotates over, the arm comes down, pushes the two ends together, and it holds it for a few seconds to make sure the bond is complete. Bottom gripper releases, the arm comes up, and now that released, but in reality, when this is complete, there will be some sort of a rack that it'll hang it on, a conveyor system where it can cure. So that hasn't been done yet. This is strictly the bonding portion of it. So the arm went over and got a second loop. Again, adhesive application. Bonding. And you'll notice this rack continually increments forward once this operation is completed. So at this point, as you can see, it's continuously working down the line. When it gets to the end, everything will go back to home. The operator will lift this rack off, which is empty, and install a new one. There's no bolting it down or anything, it just slips in here and hits the start button and the process starts again. And that pretty much concludes the overview. I'd appreciate any comments you might have. Thanks a lot. Bye.